Okay, so today we'll talk about cognitive aspects of design. So with cognitive aspects of design, we are looking at cognition. So cognition encompasses the various mental processes such as thinking, remembering, learning, and decision making. So there are different ways that we can classify cognition, which includes the experiential and the reflective cognition. So with the experiential cognitions, it distinguishes between the immediate and intuitive experiences. So the experiences that you experience by doing a certain thing or by interacting with certain technologies, you build some experience from it. And the reflective cognition, you have to deliberately sit down and analyze or think about that particular technology because you have not experienced it. So you have zero experience with it. Then we also have fast and slow learners. So there are people that they can actually think fast and there are people that they can actually think very, very slow. So those who think fast make distinction between quick instinctive thinking and the slow thinkers make deliberate and effortful thinking. It means it takes those people who have experienced a lot of interaction with computers or technologies easy to recognize things. And the slow thinkers, they need to deliberately sit down and make some effort to think before they'll be able to interact with a particular system or the particular technology that they are dealing with. So that is the ways that we can classify cognition. Experiential, which is based on the experiences you have built, and the reflective cognition, of which involves deliberate and analytical thinking. Then the fast and slow thinking. So these are the ways that we can classify cognition. So in actual sense, you could see that there is a correlation between the reflective cognition and slow learning because all of them involve deliberate and analytical thinking. But for the experiential, because they have experienced the interaction between that particular system or that particular technology, it is very fast for them. So the experiential goes hand in hand with the fast, and the reflective cognition goes with the slow thinking. So why do we have to understand users in respect to the cognitive aspect? So interacting with, with technology involves cognitive processes, which means before we're able to use a system, there are some learning things, or we are able to think, we should be able to think and make some decisions before we can interact with those things. And it is very crucial to consider those cognitive abilities of a user because all users are not the same. And we just saw that some of them are fast learners and others are slow thinkers. So we need to consider their cognitive ability before we can, and we factor that in our design because we are designing for the users. So understanding these users' cognitive ability will help them determine the user's capability and limitations and identify and explain user problems, provide theories, models, guidance, and methods for designing better interactive products. Because if you know that, okay, this particular group of people that I'm designing for, maybe they are fast learners, you know how to combine your design to make it ACIly friendly or to make the user easily interact with the system that you are. But let's say you are designing a system for people who are slow thinkers. It means, and you use features that are meant for people who are able to think very fast. It means those users cannot use your system. And that's what we are trying to prevent in ACI because we wanted that anybody who is trying to use our system should not get any help anywhere. The person should be able to still interact with the system without asking for any help. So understanding the user's cognitive capability is very, very crucial. And these are the ways that it helps the user. So let's talk about some of the cognitive processes. So we have one, which is the attention. So attention is the ability to selectively focus on relevant information. So if a lot of things are happening, or you have a lot of information displayed on a particular computer or a particular technology, the ability for you to focus on relevant information. You are filling a form, you need username and password, but you can sometimes see remember me. You can sometimes see do you have account. If you don't have account, log in here. But the most important thing here is for you to pay attention and enter your username and password. So the ability for you to focus on the relevant information that you need is what you call attention. Then the next one is perception. So the perception is the process of interpreting sensory information and giving it meaning. So perception differ from one user to the other because how I'll perceive one thing might be different from how somebody will also perceive another thing. So the process of interpreting those sensory information, so you sense, okay, you see maybe this computer mouse is maybe that size is bigger to you, but another person might see it to be smaller to him or her. So you need to consider all these things. So how the person perceive something or perceive information and give meaning to it is what you call perception. And the next one, the next process that I talk about is memory. So the memory is the encoding and storage and retrieval of information. So one, you encode. So maybe you are interacting with a certain system. Maybe you want to print. So first, you know that, okay, if I click this, it prints. So you encode it and you store it in your memory. Then after that, anytime that you try to interact with the system again, and you see the print there from your memory, you were able to retrieve that, okay, this symbol means that I am printing something. So memory is just encoding, storage, and retrieval of information. Then learning. So learning is the process of acquiring knowledge or skills through experience or instruction. So there are two ways that you can learn. It's either you learn through experience. So you are exposed to certain technology for a while, then you learn through that, or you use instructions where they give you a series of instructions for you to follow. So if you follow those instructions, you know that you have some idea about it. So now you are acquiring the knowledge through instructions, or you can acquire the knowledge through experience by the frequent interaction with certain things. You are able to build knowledge or gain skills from it. So that type of process is called learning. You can either get it through experience or instructions. The next process that we talk about is the reading, speaking, and listening. So those ones are the language-related processes which are involved in communication. We read, we speak, then we listen. So these are language-related processes. Then the next one is problem solving, planning, reasoning, and decision making. So the problem solving, planning, reasoning, and decision making is a higher level cognitive ability that differs per every user. So every user's ability to solve problem, ability to plan, and ability to reason and make good decisions differ. So when the system that we are designing, we know that we are designing it for a very vast number of people. So we need to consider these processes whilst we are designing the system or the technology. And also this problem solving, planning, reasoning, and decision making, it's a high level cognitive ability used to solve problems, and it makes plans, you think logically, and make informed choices. So you have to be able to first think logically. You plan, you think logically, and you make informed choices. So it involves a lot more than the attention and the perception. Those are lower level cognitive ability, because the problem solving, you're actually sitting down to brainstorm and bring out some key ideas or key things you want to involve in your design. So those ones are higher level cognitive abilities. So now we are taking them one after the other. So with the attention, we are selecting things to concentrate on from our surrounding stimuli. So it enables us to focus only on the relevant information. So whilst we are designing our system or we are designing our technology, we need to put ourselves in the shoes of the user that, okay, this thing that I'm designing, we need to let the user focus on only the important or relevant information. So the process of you focusing on the relevant information from the distorted ones is what you call attention. And it can involve both audio and also visual senses. So what you hear and what you see, you can pay attention to both of them. So there are some sound that you don't want to hear, so you don't even think about them. You don't pay attention to that side. And there are some videos, if maybe you are watching a video or something, there are some part that you choose to ignore. You don't pay attention there. So it can be both audio and video. And it is focused and divided attention. Focused and divided attention allows us to be selective or limit our ability to track all events. The thing is, users cannot track all the events that happens in the system. So there are some parts that they are supposed to be focused, and there are some parts that they are not supposed to pay attention there. Example, if let's say a user is maybe scrolling through your application and maybe the privacy policy, most of the time we are supposed to read it, but we just go click next, 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 and go. That one, it doesn't really, it requires attention, but most of the user settings, it doesn't really need that attention that much. But when it gets to, let's say, enter password, you see that you have to be focused all your senses there, so that you have to be selective, because you cannot track all the events that is happening in the system. Also, structuring information at the interface to capture users' attention. So we use some perceptual boundaries such as windows. So you have created a system because you want the user to focus on one exact thing from the surrounding stimuli. We can use windows. So anytime that you open your, let's say, file manager, it opens a window covering the background for you or covering the desktop for you. Or if you open an application, if you open an application, that is only the applications window that opens. That helps you to pay attention or be focused on that particular thing that you have opened because there could be a lot of things on the system. But the one that they want you to pay attention to is the one that is in the window. So the window is serving as a boundary for you to focus your attention on, right? And also, we can incorporate color, video, sound, and flashing lights just to get your attention. So this is some attention activity that are behind here. So if you are giving, if you have designed a system like this, and they tell you to find the price of double room at the Quality Inn in Pennsylvania, you can see how crumbled the whole thing is. So it will take the person a lot of time to find double room at Quality Inn. It will take the person some time to find this. So if you design something like this, you are not considering the person's cognitive ability. One, in regards to attention. So the person has to now focus through the entire list and try to read and see where he can find Quality in Pennsylvania. So this is one activity that we can do to. So you can see that the Quality Inn is located at this side here. So it took me a lot of time for me to actually find where Quality Inn is located. So activity 2, now find the price of double room at Holiday Inn. Now you see that it is in Colombia. Now you see that the interface is more clear enough for me to easily find Holiday Inn in Colombia, which is this one here in Colombia. And if you compare it to this one, you see there's a vast difference in between. So how we designed our system or we design our technology, we need to pay attention. We need to pay a critical look at the attention, how the user is able to focus and make and easily find things around because our cognitive abilities are not the same. All right. So the findings. So it was found that in a toolist found out that the two screens that I showed earlier, the activity one took an average of 5.5 seconds to search, but activity 2 just took 3.2 seconds because of how it has been organized. So it makes it easier for them to actually see. Why? Since both display have the same density of information, the spacing played the role here. So in activity 1, the information is bunched up together, making it very hard to search. But in activity 2, the characters are grouped into vertical categories of information, making it very easy for the user to identify the price of the hotel room that they were talking about. So designing for attention. So how can we design for attention? One, make important information salient and noticeable. So if you want the user to quickly know or quickly see that okay, this thing is this particular information is key, make it noticeable. So you can use techniques such as color, ordering, spacing, underlining, sequencing, and animation to make the elements stand out. So by making the element stand out, it is easy for the person to easily locate it or notice it. And also avoid cluttering the interface with excessive information together. So you just crumple all the information together in an interface. It makes the user or it takes the user a lot of time to actually find it because the information are cluttered together, so he can't decipher which one is he even looking for. So we have to avoid cluttering of interfaces, and we keep interfaces simple and clean for improved usability. So in as much as how complex the system is, let's try to keep our interfaces simple and clean because that is where the user will be talking or will be communicating with the system that you have created. So if you have created a very good system, but the interface is so complex and not like cluttered together, it reduces the usability. It makes it difficult, even though the technology that you have built is important. But since the interface is not simple, and we are not designing for one particular person to use, but multitude, it means you have to make the interfaces simple and clean so that it will be user friendly. Then considering design interface that support effective switching between tasks and returning to previous context. So if if we have, let's say, if you are navigating through over a browser, or you are navigating on a browser on a web, you are using the web browser, and you want to switch tasks and you want to return to the previous context or the previous page that you have to make the interface so usable or so user friendly that just with one click it sends you to the particular place that you were before. But if the person is supposed to go through the entire list of the page that he has visited before he gets to the previous page, it makes the whole task cumbersome and the interface very not user friendly. So we need to consider design interfaces that support effective switching between tasks. So the next cognitive process we talk about is perception. So perception is acquiring information from the environment and translating it to meaningful information, meaningful experiences. So design representation that are easily perceivable by users. So there are certain representation or there are certain design that it is easily perceivable. So once the person sees it, you know that it does that. So you ensure that the text that you are using for your design is legible and easily readable. So you're talking about the font size here, the font style. So there are some font style that you use. It makes it very difficult for the person to even read. So it is very legible. But you should try as much as possible that the text that we are using for our design is legible and it is easily readable. So we can also create icons that are distinct and recognizable. Now, anytime that anybody looks at, or maybe you are using a system and you see a printer icon there, you know that if you click that thing, it prints for you. So these icons are distinct and recognizable. But if I should put a different icon that does not represent printing there, it makes it difficult for the user to actually see the use of that particular icon. So the user will tend to ask that, okay, what is this used for? Of which we are trying to avoid. So we should use icons that are distinct and recognizable. Then we should also consider the visual clarity and use appropriate visual cues to enhance perception so that immediately the person sees, he knows what he is dealing with or he knows what he's actually interacting with. So, perception, if you have an activity for perception, so is color contrast good? Find Italian. Find Italian. So we have a lot of things here, but we want to find Italian from the list of things that we have here. You see, it will take much of a time for us to actually find where Italian is located. But let's look at this. Are borders and white spaces better? If you look at this and look at this, it is acting as a color contrast. So I think there's a blue background here and there's a white background here. So, and we said that whilst we are designing for perception, we should use design cues that will help the user easily notify things. So Italian is located here on the third pin. And now they said we should find French. Are borders and white spaces better? So now it's more or less like we have categorized them or we have broken them into sections by using our borders and our white spacing. So we are supposed to find French. So we see French is located at the side. So does borders and white spaces make designs better? So you could see that here, when it was clambled together, we had to look through each and every one. But for the borders and white spacing, it has categorized or it has grouped the kind of things that we are searching for. So when you come here, you don't see it there. You know that this is distinct from the other. This side is distinct from the other. So borders and white spacing make our perception, how we perceive things, much, much easier. So the findings based on activity 3 and activity 4. So Weller did a study on grouping and search efficiency and found out that people took less time to locate items when they were grouped together using border. So when you group things, people take less time to actually locate it compared to when you use color contrast. So when you look at this one, when they use the color contrast, it took people more time for them to actually find what they are looking for. But when they grouped by using the borders and the white spaces, they were able to find it much easier. So some argue that the excessive white space on web pages can hinder the search processes and make it difficult to find information. Now, the impact of white space on search efficiency is a topic of debate that we are not talking about here. So the question for discussing that, do you agree that too much white spaces on web pages is detrimental to the search process? So we answer that on your own. So the next thing is the activity. Which one is the easiest to read and why? So we have uh, 6 boxes here. We have 6 boxes here. Which one is the easiest one? Of course, the most easiest to read is the what is the time with the white background, because it is easily for us to perceive, for me to perceive. But if I look at this, the background and the color of the font that we are using is not matching, which makes it difficult for the person to actually perceive what it is. So if you look at this side, what is the time? And this one is what is the time, but orange background. And this one is yellow background. This one is blue background. But the most easiest one that we can quickly read is the what is the time, and the background is white. So you see that that one is very quick. It is very easy for us to read and notice because of the background that we have chosen. So when you are doing your design or when you are designing for users, you have to make sure that the color that you combined and even the type of font and the font size that you use is key, because it should be eligible and easy for the person to easily notice. So the next one is the design implications for user interface. So for perceptions, we are talking about perception, how people perceive things and make meanings out of it. Icons should be designed to ensure users can easily distinguish their meaning. So if you are having, let's say you are creating an icon for mouse, the quickest way that you can use is to use an icon that resembles, let's say, a mouse or a mice. For that one, immediately the person sees it, you perceive that this, when I click this, maybe to activate the mouse for me, or it will do this thing for me. So if you use icon, that the user can easily distinguish their meaning and not find any difficulty in doing so. And also utilize effective visual techniques such as bordering, spacing to group information, because when you group information or you group things together, it improves the visual organization of it. And sounds used in interface should be audible and distinguishable to provide meaningful feedback. So if you're interacting the system and maybe the system is giving, maybe it's helping you to maybe fill a form, that's it. That's the system that you are using, and you are using audio to give the instructions. The audio should be audible and distinguishable in providing a meaningful feedback. So if you maybe you're filling a form, maybe the first one, click here, click next, click this, and you are using audio to give these commands. This audio is supposed to be eligible and distinguishable so that it will provide a meaningful feedback. But if the audio is not clear and it's not distinguishable, it will make the user confused and not know what to do next. So when designing with colors, research proper color contrast technique to ensure accessibility and usability. Some of the colors that we mixed to design our system makes it very difficult for user to actually see or to actually perceive. Just as we saw earlier, that the most perceivable one is the white background and a dark font being used to do your design. For example, yellow on black or blue is suitable, while yellow on green or white is avoided because it makes the thing so you can't draw the contrast between them. So haptic feedback should be used judiciously, providing tactile feedback only when necessary to enhance the user information. So if you look at the iPhone, at first they were having the haptic touch, the home button that we had over there. So when you are designing something like this, so when you tap on it, you feel some vibrations and other things inside. So when you are using a haptic, you are designing, you use haptic, make sure you use it judiciously or by providing tactile feedback. So you know that if I touch on this and it vibrates, it means that the haptic is actually working and I'm getting a feedback so that it will enhance user experience. Because if the user press and the user does not feel anything or see anything, the user become confused and don't know what to do next. So that's perception. So the next one that we will talk about is the memory. So the memory involves encoding and retrieving of information. So you store and you retrieve. So our memory selectively filters and process information based on what we attend to. So what we attend to most, or what we pay attention to most, is what our memory selectively filters. So the thing that you do most, your brain selectively filters and process that information more faster than things that you don't really pay attention to, or things that you don't often do. And recognition is often better than recall because we can easily recognize things rather than recalling them from memory. So if you see a particular person's face, you know that, oh, this is this person. But trying to maybe remember the person's actual full name might be difficult. That's recalling. But recognition is just looking at the person and, oh, this is the person. So our brain kind of recognize things more easier than recalling them from memory. So when we are doing our design, we should put at the back of the mind that the design should be more recognizable than the user trying to remember the entire code that he's supposed to enter or the entire step that he's supposed to go through. Because if he knows that if I click the print icon, it will print my folder for me. And let's say there's also a terminal there. So for me to go and write the command, maybe print this, print that, and me just clicking on the icon to print, which one is the best? Be quiet. The most important thing is that is the icons on, because that one is easily recognizable. We can easily recognize it than we recalling the code from our head just to print something. So why don't you then embed the code inside the icon so that the person just click on the icon, recognizable. Then it makes the thing more user friendly than he remembering everything from the head and recalling. And since our brain does better in recognizing things than recalling, all our designs is supposed to be easily recognizable. And interestingly, research suggests that we remember less about objects we have photographed compared to when we observe them directly with the naked eye. So there are some people that the movie that they watch in KG, they still remember every little scene inside because they can recognize it. All right, yeah, so that is it. So memory, context is important. So the context in which the information is encoded plays a significant role in its subsequent retrieval. So people find it difficult to recall information that was encoded in different contexts. Example, if you're on a train and someone comes to you and say hello, you don't recognize him for a few moments, but then realize it is one of your neighbors. You are only used to seeing your neighbor in hallway of your apartment, and seeing him out of the context make him difficult to recognize. So you know that every day you meet this person in classroom, and all of a sudden you have met this person somewhere, let's say in the mall. You see that the person usually appears in the classroom, and now the person is appearing in the mall. At this point, the context is different. You have a classroom context and a mall context, of which your mind has encoded that you often see this person in the classroom. So anytime that you see the person in the classroom, you can easily recognize the classroom. You can really recognize the person that, okay, this person came to class or not. But if you see the person in the mall, you might not be able to, or to take a few moments for you to recognize the person because that is not the setting or that is not the context that was encoded in the brain. So in memory, context is important. So the context to which the information was stored plays a significant role. So if maybe you were happy and you stored a certain information, and if you are sad and the same information pops up to you, it may take you some time for you to actually recognize it or actually retrieve that thing. Why? Because the context is different. So context is important when it comes to memory. So recognition versus recall. So if you're using command-based interfaces such as the terminal or the command prompt, it often requires the user to recall information from memory, such as recalling a specific name from a large set of options. So let's say you are printing something to the screen, or maybe so instead of writing the command, why don't we put an icon there so that to make the work much easier? So graphical interfaces, on the other hand, provide visually based options like menus, icons that users can browse through until they realize their desired option. So you want to display the content of, let's say, a folder to a user, and you tell the user to enter the command for displaying all the content in the user. So instead of maybe typing the maybe ls, those commands, those plenty commands, why don't you just create a folder and a menu so that the user will just look through by just scrolling down or scrolling up to select his desired option. That one is much, much more easier and much, much more better than the person writing the entire code just to display something. So that's why we prefer the graphical interfaces to command-based interfaces. That's why now most operating systems and other things are even switching to the graphical mode because that one is more user-friendly. Because what if I forget the command for displaying that thing? It means I can't use the system. But if it is a graphical interface, at least I can perceive and I can I can recognize it that, okay, if I see that there's a printer there, if I see that there's a red button with a kind of circle and a mark inside, I know that's a power off button. So just by seeing this, I know that if I click on it, it will power the thing off than me writing the entire command for powering off. So graphical interfaces, on the other hand, provide the visually based options that help us to easily navigate or interact with systems. And web browsers enhance recognition memory by offering features like tabs, because we mostly set a lot of things with our browsers. So the browsers keep tabs for it. Okay, this tab contains maybe Google, this tab contains maybe YouTube, this tab contains that, so that you don't have to recall the website that you visited. So you just go to that particular tab and you get it. That's why they said recognition is better than recalling things from memory. And the history list. So any website that you visit, it keeps a history in the stack for you, so that anytime that you want to visit that website, you just go to your history, you click on it, and it sends you there. That one is far better than you trying to sit down and remember all the websites that you have visited. It is not possible. You can't recall all of them. So web browsers also enhances the recognition of memory by using the tabs and the history list to allow the users to easily recognize and revisit already accessed web pages. So memory, the problem with the classic 7 plus or minus 2 theory. So George Miller in 1956 proposed some theory that it talks about the amount of information that people can actually remember. And it says that people's immediate memory capacity is very limited to 7 plus or minus 2. This theory has been widely used in interactive design to determine the number of options to display. However, its applicability and usefulness in the field of human-computer interaction are subject to debate. Questions arise regarding whether relying solely on the theory is good or not. So, what do most of the designers do? The rule of 7. Most designers adhere strictly to the rule of 7. So it means that anything that they designing, if he's designing, let's say, a menu, so that the user can select an option from, he has to limit the number of elements that goes into the menu to 7 and not above or below. So they limit the number of options on the menu, icons on the toolbar. So if you take a toolbar, the icons on it, they limit everything, or even bulleted in the list, items in the drop-down menu or tapped on the web page to 7. So there are some browsers that you can only open 7 tabs, but those are old web browsers. They are no more. But now you can see that this one does not really actually hold, because people tend to visit so many websites in a day. So limiting it only to 7 will make your system not user friendly. What if the person wants to add another type to it? It means the person cannot. However, this approach may not be appropriate. Limiting option to 7 based on this rule can be misleading and oversimplified. The rule of 7 is not universally applicable and may not consider the complexity of the task or the cognitive ability of the users. Some users' cognitive ability is to just work with some 2 elements, and you're giving the person 7. So you see, the person will be falling short there. Some people too are fast thinkers. They can process a lot of things very fast. They can consider high complex things. And you have limited the person to 7. The person will not feel comfortable using the system. So the rule of 7 is not universally applicable, and it can be misleading, because now people can open like 20 tabs in a day. So now you have limited everything to 7. So it means the person cannot open even the 8th tab, which means it will make the person not be able to interact with your system more efficiently. So the limitation of the rule of 7 in UI design. So the rule of 7, which suggests limiting the number of items to an interface to 7 plus or minus 2. So it means it can be 5 to 7. People can easily scan list, tab, and menu items to locate the desired option rather than relying on memory recall. So what you are trying to avoid is, don't allow the user to try to remember something. Immediately the person sees it, let the person easily recognize it and interact with it. This means that the interface can accommodate more than 9 items without overwhelming the users. For example, if you check the history list in web browsers, it can include a large number of visited websites, but they have grouped them together. Maybe today, the number of websites that you visited, yesterday. So when you click on yesterday, it closes the today's one and open the yesterday, the website that you visited there, making it easy for the person to what recognize it. Immediately he sees yesterday, you know that okay, we are talking about yesterday, so I'm not talking about today's own. So the rule of 7 may not be ideal in UI design because the interfaces can accommodate more items without overwhelming the user. So in some cases, a small number of items can be beneficial, such as if you are dealing with a smartwatch or the Apple Watch and things, and you increase or you put a lot of options on it. You know, the screen size is small and it is limited as compared to our laptop screens. Or so if you are designing an application for Apple Watch or maybe Samsung Watch or any smartwatch, and you are designing the same system for let's say a computer or let's say a desktop computer, the design or the UI design of the Apple Watch should be different from the UI design for the computer because even the screen is a limitation there. So you don't want to crumple everything on the watch so that it makes the users difficult to even navigate around. Yeah. So the suitability of the rule of 7 depends on the specific task requirement and the screen available. So if you want to apply the rule of 7, you check your screen size. If I put all the 7 items there, will it fit? Will the user have some easy way of navigating the system? If the user will not, why don't I split it into let's say 4 3 so that the first pane will display 3, the next pane will display 4, rather than putting all the 7 together. If you have a wider screen and you're doing it 1 1 1 1 1, you are wasting space. So that one, you know that the screen is big and the specific task that you are doing. So maybe I am logging in. So I just need the login. I just need the login button. So I just put that one there and I'll allow the user to enter. Now I'm designing the same login for a watch, which the screen is very small. So I can say that, okay, now first enter your username. Then when you click next, you enter your password. I'm making the thing very user friendly rather than me putting everything together. Please, okay, so that is it. So it is important for designers to consider the context, the user preferences, and usability testing when determining the optimal number of items in an interface. So the number of items that you are supposed to use in an interface, you have to actually consider the context where we are actually creating it. Then the user's preferences, what the user wants, and how usable or how user-friendly the design that you are trying to do will fit the user by determining the number of items that you are supposed to put on a particular interface. Because if you have like 14 fields in a form and you are displaying it all on a small watch, it makes it even difficult for the person to even read it. But if you display the same thing on the computer, it is easy for the person to recognize it. So that is why the context is key there. So by blindly adhering to this rule, designers may inadvertently sacrifice functionality, user experience, and efficient navigation. So if you try to always put everything 7 on the interface, always try to figure everything out or merge everything together on a one interface, you are sacrificing the functionality and the user experience and navigation because you make it difficult for the user to actually navigate his or her way around. So the digital content management, organizing and finding files. So now with the increasing volume of digital content that we have now, users face challenges in managing and locating their files. One, remembering file names and where the file is stored can be difficult, which require the recall that we are trying to avoid. So it can be recall directed or recognition-based scanning process. So file management system should be designed to support both memory processes efficiently. That's the memory processes can be recall or recognition. So now you are saving your file. We can add some tag to it that, okay, maybe this file is for school files. So immediately you see school tag attached to that particular file, you easily recognize that, okay, this file is this, which helps in easy navigation or easily searching or scanning for files. Features like the search box, so you just enter the name of the file, then it brings it up to you. and history lists can aid in quickly locating files based on recall or recognition, but try as much as possible to involve the recall or recognition. So some people actually tag all their files or their folders with a particular color so that they know that, okay, this color belongs to maybe schoolwork, this color belongs to maybe office work, this color belongs to maybe home files and other things. So that immediately he sees that, okay, I'm looking for home files, he knows that I'm going to the green. If any file that I see that is green, I know that's the home file. So that one easily makes searching and scanning for file objects or files much, much easier than for you to sit down and scroll through the entire file system just to look for certain things. And the search box. So you see, one, we are designing for people who are slow thinkers and people who are fast thinkers. So if you can recall things fast, you can use the search box to search the file name, you go away. But if you can't think fast or you are slow, you're a slow thinker, you can just use the colors or the text to easily recognize that particular file that you are looking for. Then you find it. Okay. So to enhance file organization, user can be provided with options to encode file in a more richer way. I've talked about this already, which is using colors, flags, images, flexible text, and time stamping. So you know you are searching for something. You know that you created a file yesterday, but you have a lot of files there. You can use timestamp so that you know that, okay, now I'm searching for files that were maybe 5th March. So you know that all the files and the 5th March will just pop up, which makes it easy for you to find files and organize all your folder structure. So these features enable users to visually and contextually categorize and remember their files. Whether you are a fast person or a fast learner who uses the recall, or whether you're a slow learner which uses the recognition, you will still be able to interact with the system. So if the system you are building will involve some file management inside, try to consider these things in, because the users that are going to use the system might be different. So you need to consider the recall and the recognition of the memory aspect of the user. So memory aids for enhanced recall. So there are a lot of things that were developed by Microsoft. It's a wearable device that automatically captures photos at interval without the user's intervention. And there are also digital images captured by SenseCam. So the digital images captured by SenseCam are stored and can be revisited using specialized software. Now, studies have shown that SenseCam can improve memory, particularly with individuals with dementia. Another memory aid is REM-ARC, which utilizes the archived BBC material to trigger long-term memory. So these are just memory aids. Maybe people who have maybe low recall, maybe they are slow learners. If you want to aid their memory, these are some of the things that you can use. They are mostly softwares which are developed by these tech companies. So this is the SenseCam in action. So if you want to maybe recall what you saw maybe in a day, this SenseCam takes images as you go about your daily activity. Then after that, you sit down and okay, I met this person, I met that person, which aids in recall of in case you meet that particular person, it aids in you recalling the person or you recognizing the person, depending on how your maybe whether you're a fast learner or you are a slow learner. But they are mostly used for people who cognitive capabilities are very, very low. Yeah. So now, how can we design our UI or our system for memory enhancement? One, minimize the cognitive load. So if you have a more complex task procedure for the user to do, try as much as possible to simplify those procedures to reduce the mental effort required for the user to carry out tasks. So the user is, let's say, supposed to log in into a system, register and print. So you can actually simplify these tasks so that the memory processing that the person is supposed to use to carry out those tasks will be minimal. And once the task does not involve so much mental capability, it makes it easier for them to interact with the system. So let's try to minimize the cognitive load because the users are different on different other skills. Then we should emphasize on recognition. So we should design interfaces that prioritize recognition over recall. So it allows users to easily identify and locate information without relying heavily on memory, so that if I see the thing, I can just easily recognize it rather than recalling it directly from memory. Then utilize multiple labeling methods. So provide users with some diverse methods or options for labeling data information to enhance recognition and retrieval. Then use folders and categories. So organize files into folders and categories so that in case somebody is searching or navigating around that file structure, the person can easily and efficiently navigate and find what the person is using or looking for. So incorporate color coding. So you need to apply some colors to visually differentiate and group related information. So you know that this information belongs to this particular location or this particular group. You can use colors and other things to identify it. So immediately you see that this is a red color, you know that okay, this red color belongs to, let's say, school file. The green color refers to it belongs to maybe a home file or something. Yeah. And implement flagging and bookmarking. So this allows users to flag or bookmark important content for quick reference. So in our browsers like this, if you are working on a site or you are browsing a site and that site is important to you, you can either bookmark it so that anytime that you want for quick reference, you can easily go to that bookmark location to just go and access that site. Then utilize time stamping to automatically record and display the time stamp to help users track and record the chronology of their digital information. So you just put the timestamp. Okay, this I created this file on this day at this time. So anytime that I'm looking for folders or files that were created on, let's say, 4th March, I'll not go to 3rd March because I will just go to the time. I'll just key in the time that file was created, and it just brings me all the files or the digital information that I've saved per that time. And also consider users' preferences. So you have to provide like customization for labeling options, allowing users to personalize their organization and retrieval strategies. So how the person wants to retrieve his information, you have to give the room for it so that you customize how the options. So if the user wants to display the thing in a list form rather than displaying it in a tab form, you need to allow, because some users will want to uh, display their folders in a list form. Others too want it in a tab form. So you need to take into consideration the user's preference so that the user can easily organize and retrieve his or her data that he is looking for. Now, the next process that we talk about is learning. So learning involves acquiring skills and knowledge through memory processes. So you acquire knowledge and skills through memory processing. So there are two types of learning. One is incidental learning and one is intentional learning. So the incidental learning is unplanned. It is spontaneous learning that occurs through everyday experiences and observation. So what you experience often, you learn from it. So that type of learning is what you call the incidental learning. And it is unplanned. It's not like it is unplanned or it just happens as you experience the everyday activity that you do. And the intentional learning, that one is a deliberate and purposeful learning, often involve studying or training. So maybe you have not used a certain system before and you want to learn or you want to learn how to use it. That one is not unplanned. That one does not, you are not exposed to that system every day. But that one is deliberate. You sit down and you purposefully learn to understand how the system works. That is why it involves studying and training. So the more you are trained on the particular system, then the more you gain knowledge and skills from it, right? Yeah, so that is it. So this is a deliberate and purposeful. While the incident one is unplanned and spontaneous, and it occurs through the experiences and observation that you've seen. So an example is people who are learning, let's say, carpentry, or maybe people who are learning baking or hairdo or something. They don't sit down to maybe teach them, they do that. As they are watching, then they are learning from it. So that one is spontaneous. It occurs everyday experiences. But the intentional one is, let's say, they teaching you coding and other things. So that one you sit down and you purposefully learn to gain the skills and knowledge. Now, various technologies have been developed to support and enhance the learning process. So we have the multimedia, we have the animations, we have the virtual realities. All these help us to learn things more. So instead of first thinking in abstract, now you can actually put on maybe a virtual reality to actually realize whatever you are learning in the real world. That one helps you to learn more faster. Yeah, so these are some of the technologies that have been developed to aid or enhance the learning process. So people tend to prefer learning through hands-on experience rather than relying solely on the instruction manuals and passive instructions. So most of the people actually want that hands-on practice, because the more you practice hands-on, then the more you actually gain more insight rather than using the instructions. Do this, do that, do this. But the hands-on experience is more preferred. So people prefer hands-on experience rather than instructions. So when you're creating your system, and you can tend to add some maybe a visualization of how the system looked like rather than giving them a list of instruction or a list of manual for them to follow, because some of them will not even read the manual itself. But when you add the visualization or the real maybe a simulation of how the thing work, it makes the learning easier, because maybe the person is not even familiar with the content of the manual. He doesn't even know, but the person seeing, that's why I say recognition is better than recall, because recall, it involves more cognitive processes. That is why people prefer the hands-on experience rather than the instruction manuals. So how can we the design implication for enhancing learning? So we keep speech-based menus and instructions concise. So if you have created a system that uses speech assist instructor. So if you want to maybe click here, move to this, do that, do this, and it is speech based, you have to make it concise and precise, because otherwise it's going to confuse the user rather. And pay attention to the intonation of the artificially generated speech, as they may be more challenging to understand than human voices. So that's why I think there's Microsoft Edge where it can read your text for you. So they give the option for you to choose. So the tonation of the artificially generated speech attention should be paid there, so that it makes the user easily understand. Because if the tonation is not good, it becomes more challenging for the user to actually understand, because artificially generated speech is sometimes quite different from the human voices. And also allow the user to increase the text size on the screen to improve readability. So whilst you are designing your system, don't make it fixed. That's why they said there should be customization there. So give the user the room to increase the text size, because maybe the person is suffering from maybe size, they're having an issue with the size. So you need to increase the font size or reduce the font size. You need to make room for that. And also design interfaces that encourage exploration and active engagement. So if you have designed a system and the system is boring, it is just boring. People cannot interact with it more easily. People will not tend to even use the software. Maybe the software might be good, but because it does not involve any active engagement. So you can put some animations and other things inside, so as to encourage the user to continuously use the system. And also provide structured and guided learning experiences through interface design. So you can provide structured and guided learning experience. Just like nowadays, some of the systems that we have or some of the softwares, when you click, it just gives you some page. If you want to do this is how you go about it. So guided learning experience through the interface design. So even if the person does not know how to use something, the guided learning experience that you have involved or you have inculcated in your design will help the user to use the system more efficiently without asking anybody's help. And also utilize dynamic linking of concepts and representation to facilitate understanding of complex material. So if the system, maybe you are supposed to uh, do some, enter a series of tasks, and the task is complex, you can use dynamic linking of concept to break the task down to a more simpler one, so that the user can easily complete that task. So some diagrams, some representation to help the user actually understand what he is doing. So instead of just clamping all the tasks together to make it complex, try as much as possible to use some linking concepts. So you link one of the concepts to the other, just trying to explain the complex tasks that we have, right? Yeah, so that people can easily learn and utilize the system that we are trying to do. And the next on the list is the reading, speaking, and listening. Now, the ease which people tend to read and listen differs. So people read easily. People too takes a very is challenging for them to actually read. People can easily listen attentively. Other people cannot do that. People can speak. Other people cannot speak. So it differs. They are not the same. And these are the people that we are designing our system for. So many users prefer the auditory information over written text. So people prefer to hear things rather than you writing it for them. That is why most of the systems that are coming now are speech based for the instructions. Now, reading can be faster comparing to speaking or listening. If I read now, of course, it's faster than speaking or listening. Now, listening requires less cognitive effort than reading or speaking. That is why now many people prefer the auditory information because you are just listening. You don't need so much processing. But when you are reading or speaking, with reading, you have to first read the content, then make meaning out of it. Then the speaking, you have to first think before you speak. But the cognitive, but for the listening, you are just listening. So that one is less cognitive. It doesn't involve much. So dyslexic, dyslexic individuals may face difficulty in understanding and recognizing written words. So if you are designing your system, you need to consider all these things because all the individuals are not the same. That is why they read, they listen, they speak differently. It differs. So you need to consider all those things when you are designing. So if your system will involve reading, speaking, and listening, try as much as possible to make the auditory or the speech-based one more than the written text. So some applications. So voice user interface allows users to interact with them. Example is the Google Voice, the Alexa, the Siri, the Big by Samsung, and those kind of voice user commands. So this speech output system use artificially generated speech. Example, the text to speech systems for the visually impaired, then the natural language system that enables users to type in questions and give text-based responses. Example is the chat box. So applications of reading, speaking, and listening. So we can use them in our voice user interactions or interfaces. We can use them in our speech output systems. We can also use them in the natural language systems where you type in your question. Example is the chat GPT like those. You just type in the question and it gives you a text-based response. But for the voice, you just ask a question using the voice and it responds by giving you a voice-based response. So these are some of the applications of the reading, speaking, and listening. So how can we, when we are designing for reading, speaking, and listening, what are the things that we should take note of? One, we should provide options for audio-based content to cater for users' preference for listening because people prefer to listen more than reading and speaking. So we need to provide that option that in case maybe you are designing maybe your, let's say, your system, it is text-based rating. You can involve or you can provide an option for the audio base so that the person who wants to listen can easily listen to whatever your system is trying to do rather than the person reading because the users are not the same. And also provide options to increase the size of text on the screen, ensuring that users with visual impairment can comfortably read the content. And design interfaces that facilitate efficient reading, such as clear typography and appropriate formatting. So make sure that the typography that you are using and the formatting that you are using is good in terms of user usability and it is clear so that the user can easily recognize it and it is legible so that the person can also read it or not have difficulty finding it or difficulty in reading it. And use concise and accessible language for spoken instruction or text to speech functionality. So when you are using the text to speech functionality, most of them you write them you type them in words, then it gives you an output of speech. So when you are using such kind of functionalities, you have to make sure that the language of which the system is going to respond with is concise and it's an accessible language so that at least the user can easily phantom himself with it or the user can easily acquaint his or herself with it. So you use concise and accessible language for text to speech functionalities. And also, you incorporate features like the dyslexia friendly font and customizable reading settings to support users with reading difficulties. So when the person can't read, you provide an option for the person. If the person can choose or chooses to listen, you also provide an option for it. So no matter the category of people or users that you are dealing with, they will still be able to use your system, which is based on reading, speaking, and listening. So you kind of encompasses all of them together. So no matter where you belong to, you'll still be able to still use the system. Then cognitive prosthetic devices, implication for design learning technologies. So with the increasing reliance on the internet and smartphones for information retrieval, it reduces the need for extensive memorization. Now the internet is there. So for us to memorize a lot of things in our head, it has reduced because I can just check it up on Google or maybe check it up on Bing somewhere and get that information. And now almost everyone has smartphones, so information retrieval has become much, much more easier. So the expectation of having internet access impacts our memory by prioritizing the knowledge of where to find information online rather than storing it internally or inside our head. So people tend to prioritize information. So you know that okay, why am I keeping this in my head? Whilst I can just check it online. So now the rise of internet access has impacted how our memory works, or by prioritizing the information of or the knowledge of where to find information online rather than to store everything inside here. At first, when you're able to store things inside, it's where maybe they call you good or something. But now people are prioritizing because it can be found online. So why do I have to keep it internally? So designing technology to support learning should consider the shift in reliance on external information sources and the implication it has for the learning process. Now, because everything's almost online, so why should I keep things in my head? So the system that you are designing, design it in such a way that it supports learning in case there's a shift in the reliance. Because now the internet is almost everywhere. And you see, they say that the internet almost contains everything that we need to know. So as people are now shifting to external information sources, how does your technology still support learning? Because how should I grab the process of maybe uh, logging in and logging out of your system in my head whilst I can just check online? So whilst you are designing your technology, you have to make sure that your technology still supports learning, because we are acquiring the knowledge, whether it is incidental or whether it is intentional. It should still support learning of the user so the user can easily interact with the system. So these are some of the impacts of the app mentality on decision making. So the dilemma. So younger generation growing reliance on application is leading to increased rates of aversion and difficulty in making independent decisions. So now with the growth of apps and these AI things now, people don't tend to make dependent decision. They have to go and check when we consult other things. So it's kind of have impact on our mentality or our memory. And abundance of app provide ready-made solutions for the various tasks, reducing the need for critical thinking and problem solving. Now, if they give you an assignment or maybe you give you a work or a task that you think is too much for you, you just don't have to stress yourself. They just go online, then they just search for it. So it reduces the need to actually think critically, and the problem solving skills is actually reduced because now you just send it to these AI people and they'll just do the work for you. So relying heavily on application can lead to anxiety and lack of confidence in making decisions without the app-based guidance. What if AI is not there? Can you still think critically? Can you still be problem solving? Can your users still do those things? So relying heavily on these apps can have a negative impact on us. So cognitive frameworks, understanding the user behavior at the interface. So cognitive frameworks are utilized to explain and predict user behavior when interacting with user interfaces. So they are based on theories of behavior and focuses on the mental processes that occur during an interaction. So these frameworks also consider the role of artifacts and representation in shaping users' cognition. So as the user is interacting with the system, these cognitive frameworks are used to explain and predict the user's behavior. It's just like these AIs, when you log on to these YouTube and other things, the things that you are searching, those algorithms, the next day that you open YouTube, they'll bring you the curated of what you searched previously. So they are using it to predict the user's behavior when interacting with the system. What was the user's reaction when he saw the homepage? What was his reaction when he was logging in? So these frameworks help us to explain and predict. And it focuses on the mental processes that occur during the interaction. Is the person struggling? Is the person mental load overwhelmed? Is it taking so much time trying to figure the system out? So these frameworks help us to do that. So some of the well-known cognitive frameworks include the mental models, which depicts users' internal representation of how a system works. Then we have the gulf of execution and evaluation, which describe the gaps between users' intentions and systems feedback. So it's a reading assignment. There are also distributed cognition. There are external and embodied cognition. These are reading assignments that you can read through. So mental models. So users develop understanding of a system through learning and interacting with it. So the more a user interacts with your system, the more the user learns and the more the user understands. This means that understanding is often referred to as a mental model, which consists of the knowledge of how to use the system and what actions to take next. So if I give you a computer that, turn on the computer and open File Manager, somebody who has not used a computer before will not even know where to even turn on the computer. But someone who has had so much encounter with the computer will know the exact places to click and the exact place to go in order to open the File Manager. So how you use the system and what to do next is actually learned through the learning and interacting with the system. Understanding how a system works, particularly in unfamiliar and unexpected situations. So the mental model that you're talking about here, it consists of one, how to use the system and the action to take next, and two, how the system works, particularly in an unfamiliar or unexpected situations. So mental models enable the user to make inferences and carry out tasks effectively because the user knows the system, he knows how to use the system, and he or she knows what actions to do or what actions to take next. And also the mental models enable the user to make those inferences because the user already have idea about how to use the system. So if I know how to use the system and they give me any task, I can easily carry out those tasks effectively. So everyday reasoning and mental models. So it's an activity says, so you arrive home on a cold weather night to a cold store or a cold house. How do you get the house warm as quickly as possible? Set the thermostat to be at the highest or to the desired temperature. Or you arrive home starving hungrily. You look in the fridge and you find all that is left is an uncooked pizza. You have an electric oven. Do you warm it up to 100 degrees Celsius first and then put it in as expected by instructions? Or you turn the oven up higher to try to warm it up quicker? Which one will you do? Or which one will you do? So this one involves some reasoning and some mental or some cognitive processes. So you can just go through this, then I think you'll be fine. So the thermostat control misconception. So let's go through it. So when asked to heat up the room or the oven, that is the thermostat control, many people choose the option of increasing the temperature settings. This choice is based on the misconception that raising the temperature will heat the room or the oven more quickly. This conception stems from the general valve theory where more is more principle is common applied to the various settings such as gas pedals, gas cookers, taps, and radio volumes. So what the person thinks is that, okay, I'm hungry. I went to the house. The pizza is uncooked. So should I put it in the oven and turn it all the way up so that it cooks faster? Then it's the wrong choice because trying to turn the thermostat from 0 to 100 at a go does not actually solve the case. But there's a misconception that stems from the valve theory that the more you open, then the more the thing becomes, the room heats up. That is not the case. However, this mental model is incorrect when applied to thermostat, which operates based on on-off switch mode. So you either turn it on and you wait for the room to get heat or for the pizza to get heating up or you turn it off. So that's the difference. Or the air conditioning too. So the air conditioning, you can't just start from 20 all the way to -1 and you expect that the room will be chilled at a go. You have to take it like step by step or turn. You should turn it on. Then very gradually, then you see that the room is becoming warm. That one is more better than you just turning it all the way to -1 or negative something. So that is the thermostat control misconception. So sometimes based on the ideas that we have, we tend to do other things. So these are the continuation of the thermostat control. So misconception in understanding interactive devices. So users often hold erroneous mental models when it comes to understanding how interactive systems or devices and computer works. These mental models are often poor, incomplete, and easily confusing based on inappropriate analogies and superstitions. For example, when using elevators and pedestrian crossing, many people tend to press the button at least twice because they have the idea that if I press it once, it will not work. So they have to press it twice to actually see that the elevator is somehow working. This behavior is driven by the misconception that is pressing the button multiple times will make the light change faster or ensure that the elevator arrives promptly. So you know that maybe the elevator is at the ninth floor and the person's at ground floor. And from ninth floor to ground floor, he wants it quickly. So instead of pressing it once and waiting for the elevator to come, he'll press it many times, thinking that the more I press, the faster it comes. So these are just misconceptions about how people understand interactive devices. So when you are designing your system, you need to factor all these things in your design so that how people interact with the system will be different. So you know that okay, if I click print, it will print it. But if I click the print thrice, it means you are issuing multiple commands to the queue and you end up printing a lot of them. Meanwhile, just a single click on the print icon would have just done the job. So those misconceptions too should be taken care of. So basically that is it. Okay, so next on the list is now how do we design our user interfaces for better mental models? So one, we need to clear and easily use instructions. So clear and easy use instructions should be provided to the user to help them build accurate mental models. So maybe when the person is maybe registered the course, maybe the person is logging in, he will enter his username and password and click login like 5 times. Click, 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 click. But you can put an instruction there that maybe once I enter your username and password, just click once. That one will eradicate the superstition from there. So the person will just click once. If it is printing, the person will just click the print icon once. And we have to use appropriate tutorials and contextual sensitive guidance that can guide the user's interaction in how to interact with the interface and providing some online videos and chat box windows that offers additional support and assistance in case the user needs some help. And there should also be transparency in the interface design, which is crucial to make the system intuitive to use. Then the interface should provide clear affordances that indicates available actions such as swiping, clicking, and selecting. So your system design should afford a wide range of people. So you shouldn't take other users out. You make sure that the system that you design, if somebody wants to swipe, is doable. If somebody wants to click, if someone wants to drag, select, all these actions should be presented to the user so that the user can make the choice of it. So consistency in the design element and terminology is key. So you are designing the system and you are using Control plus S for saving. But when you get to the next page, you are using Control plus B for saving. There's inconsistency in the design element. So if the person has learned that, okay, for the first time, I use Control plus S to save. Now I'm using Control plus B, there will be confusion and the usability of your system will become difficult. So make sure that there's consistency in terminology and interaction across the system, which help the user to develop a consistent mental model. And also, users' feedback and error messages should be informative and guide the user towards the correct mental model. So the user has login, is trying to log in, and you display a very strange kind of lines of code that the error is this. That is not good. Just maybe password incorrect, enter a new password, or check your caps. If the caps is wrong, you give those informative messages so that it will guide the user to make the correct, otherwise, to make the correct decision. Otherwise, the user will keep on entering, and you tend not to even use your system at all because your system does not provide any guide to the user in case he makes a mistake. Now, conducting user testing and gathering feedback can identify areas where the users struggle to build accurate mental models. So while the user is using the system, you can test or gather some feedback from the users to see that, okay, the users are struggling at the login page. So what can I do to make it better? Then continuous improvement and updates to the UX based on user feedback can lead to development of better mental models. So this brings us to the end of the slides.